Thank you so much, Henk, for your presentation. And I would like to ask you to stay on the stage because we go to the next panel conversation. And therefore, I would also like to invite Helen Carden back together with Dmitry Pusagot and Frank Sperding for the panel discussion on AI and data. Please welcome them to the stage.
Welcome back. This is one of the, for me, this is very close to my heart when I was also working in Agis. Also the conversations you presented today. It's really nice. So we will make it into a conversation as we discussed and move forward. But before starting the conversation, I will give the floor to Dima to introduce yourself. Thanks for joining the panel.
Yes, thank you. My name is Dima Pustahot. I'm a researcher at Photonic Integration Technology Center, PITC, and I work in metrology program. So basically the topics we work with is testing and characterization of photonic integrated circuits. And we cover all aspects of it, from design of test structures, collaboration with equipment manufacturers, and also definition of test methods and data analysis.
Thank you, Dima. The topic of panel says AI and data, and of course, it can mean a lot of things. So the whole AI movement we discussed in the previous sessions and the data, but we would like to give it a different twist. So it's not about the data generated by making 1,000 pictures or TikTok movies, but rather, let's say, functional data and use of AI in the manufacturing domain. I would like to start that with Frank, with you. You also touched upon it in your discussion. As a company who actually works in mechatronics, building modules and parts, can you elaborate what does data and AI mean for you?
Is it working? Yes, I touch on. First of all, I'm very happy that the AI hype is there because that's driving a lot of the innovation. So we're grateful for that. No, but as I said before, what you see is that equipment is becoming more complicated. It's becoming more complex. The speed with which we want to innovate is the same or higher. So you have to somehow get that process running. I, of course, as I said before, believe strongly in sharing data and opening up that chain and getting, let's say, trusting each other to tackle these problems together. Of course, it has to be economically interesting also. But also the AI element in there is where we are using it as a tool to basically help the efficiency. I always say to the designers, designing is 10% inspiration and 90% transpiration. And that transpiration part, we can try to alleviate using modern tools. Yeah. That's how we approach it. I don't yet believe that AI can fully replace, let's say, the expertise that you have, but it can help you to make the process efficient and speed it up.
Okay, very good. You have something to add?
Yeah, I think that AI is a double-sided sword. It's obvious that without AI, we are lost. Yeah. I mean, in this concept of process improvement, of quality improvement, there's lots of AI in the sensoring, in vision, but there's also lots of AI in diagnostic. Those, a little while back, we would call it machine learning. Before that, statistics, all this monitoring of failure data and developing predictive maintenance from that. There is large language models and other things can be used in the training of people. Not so sure if I really want it in the diagnostics so much because they hallucinate by definition. And there's, of course, lots of vision and robotics in the execution of maintenance and operations there. So we definitely need it. It's just, I don't think we should even try to get rid of those last 10% because I do want to have some oversight.
Yeah, I wanted to mention that it's very hard to generalize AI in general. Yeah, there is different types of machine learning LLMs, as you mentioned, and each of them has its own domain of usage. So I think when talking how AI can be used, we need to be quite specific and understand which tasks we are trying to solve and which AI-based tools are appropriate for those tasks.
Yeah. Indeed. I mean, one of the topics now we talked is about really using data to faster analyze things. There, I think you mentioned hallucination, so access to the good data. So we want to avoid garbage in, garbage out concept. Access to good data is a big thing in industry. Do you have experience with that, or you have ideas how we can stimulate that?
Yeah,
to get good information that maybe doesn't exist within our own, let's say, a company's own database, but customer or supply chain has it.
Yeah, there's this good old concept in science of triangulation, having different sources. And in developing predictive models or in this context, you need data from different sources. And there we return to the problem of the supply chain collaboration, because the data that the company that does the operation, or the people that do the operations and service, is very different data from the people that actually own the machine and own the outputs or govern the inputs. And it's again different from what the OEM knows, and the OEM doesn't know everything. Some of the key suppliers know stuff. So it's essential to reduce, if you want to reduce hallucination, do triangulation. For triangulation, you need an established AI technique. It's not even an AI technique, it's federated learning, so that everybody puts in their data, but you can't see the other people's data. The only one that can see that is the algorithm.
So a trusted relationship to enable data sharing is very crucial.
Yeah, so digital trust, but starts with people trust, indeed.
Yeah. A little bit maybe switching to maybe mechatronics and expertise, and also remark of Dima about different types of AI. What sort of AI beyond just data analytics is important, like in designing or physics-based AI? Maybe, you could elaborate. Both of you could go. Yeah.
I may want to add one word to the previous conversation, because what you see happening is that, let's say, data is important and everybody's collecting data, but in my view, it's throwing out the data, which is the challenge. And so there's a model that says if you start with data and you start to bundle those data parts together, you get what they call information. You bundle the information parts together, or you actually throw out the connections you don't need, you get knowledge. And if you go to one step further, from knowledge then comes wisdom. And so there's a famous model that does that. So the challenge is not to gather the data, but the challenge is to understand which data you can kick out. So that's just one thing I popped up that I wanted to add. So the question is, what kind of AI are we using in our design? Of course, I think it's been around for a long time, which is basically for coding. So coding is now more or less delegated to AI. So all of the, let's say, people who used to have coders out in India, those people are slowly getting out of work. That's one thing. But also, in our case especially, we're looking at machine learning, because machine learning says something about how you can enhance the performance of a machine. It's not the same as the LMM, which is hot and happening, which is on top of the hype curve right now. But it's machine learning and understanding how that machine learning can help you in this case, for example, defect detection. That's one of the things we also do, defect detection in photonics chips and things like that. Yeah, but there's a lot more. And let's say as a mechanical engineer, I try to pick out the tools that I can use, but I'm not an expert in AI systems.
Okay, very good. Dima.
And to answer the remark that LLMs can produce not very high quality, let's say, data, or not the data, but designs, I think there are two ways to approach it. First is to help them to infer information from the data. So, for example, to create, let's say, physics-based models, which where we already put, our existing knowledge about the domain area into those models, and help it to create connections between the pieces of data. So that's one of the approaches. And the second, and I think it's very important, is to provide high quality data to, well, when training the models. The data which we are talking about in supply chain is very heterogeneous. It's coming from multiple sources, from foundry, front-end processes, back-end functional testing. Everybody's talking their own language, how to connect this data together. So I think there is really a large opportunity for standardization in how we describe data, how this data is connected. And also the data, how do we guarantee that the data is full, traceable, interconnected? Only then AI can, learn from it and create good models which can be used later.
Very good point. Very good point. Thanks a lot. I mean, you are from, like your expertise lies in photonics. You come from semicon domain, and you as well. Now a bit distance from AI and look at the data and lessons learned, linked to your presentation. What we can learn from semiconductor industry when we are going into photonics? Maybe start with that.
Yeah, well, as for the different processes in the supply chain, they look similar, and it's difficult to say if it's 50 or 80%. The technology isn't different. For the whole thing of the market volatility, the ups and downs that we will have also in photonics, and that we have had and will again have after this hype is over in semiconductor. That's similar. The way how you can organize your business is similar. Keep investing during your downturns, for instance, in good people. So many of those lessons learned is precisely the kind of tacit knowledge that you have when you've done something before. The knowledge that the people, we had a discussion earlier on that several of the people were around founding ASML in the 20 years ago. Now still, although they don't have to do it for the money, are involved in setting up the new photonics ecosystem simply because they love to see the buzz around it and the energy, but also because they can attribute that tacit knowledge, the knowledge of how to do it, to how to actually get this business up and running to the new generation. I think it's really tricky to assume that on the technology side, we can just Control-C, Control-V, but my fellow panel members are much more knowledgeable about that. There I would be hesitant, but all the business, supply chain side of it, let's start with copying that and let's see where it doesn't work.
Yeah. In ASML, we used to have a best-known method terminology. So it means you learn from your mistakes and apply it, same process to other domains.
Indeed.
Yeah. Very good. Frank, maybe first give the floor to you. What we can learn from, or where you see there is a synergies between semicon and photonics, and where it might be different from your perspective and for Nobelio. Yeah.
Well, from my perspective, because by now you've figured out I'm an equipment fetishist, so to say. From the equipment side, I would say there is a lot of commonality because you have to have a process. You probably will have a benefit. The faster the system, the more it produces, the more its value is. But the real value, of course, is also understanding the underlying process. I cannot go as an engineer and say, I'm good in semicon equipment, so I'm going to make a good printer, or I'm going to make a good photonic system, or I'm going to make a good whatever other device. So my guess would be 50-50. There's a lot of knowledge about making equipment, and there is commonality, but you have to understand the application data. You have to understand where the value for the customer is if you really want to turn that into something which is an interesting business, which at the end of the day we want to do in order to let it grow. So we're kickstarting it, but it has to be economically interesting. So I would say we can learn from it, but it's not copy-paste. It's a 50-50 kind of cut in there.
No. Nima, can you elaborate a bit on that?
Yeah, sure. It's actually a very good question. And, integrated photonics is much younger area of research or industry than integrated electronics. And even in these 10 years that I've been working in integrated photonics, I see a huge difference between how integrated photonics is perceived by traditional semiconductor industry. It's only in the last probably 4-5 years that we are on the roadmap for semiconductor businesses. And it's really exciting time, which means that we can really bring the expertise from all the existing semiconductor electronics manufacturers in terms of tooling methods. We can bring it and merge it with research know-hows from universities. And this is exactly what PATC is actually doing, collaboration between industrial partners, universities, knowledge centers in integrated photonics, marrying this together and moving forward the integrated photonics.
Yeah. Can you elaborate on what is different? So now you're seeing, okay, it's picking up, and indeed co-packaged optics in the, for example, roadmap of TSMC and major semicon companies. But what they have to do differently? What other challenges they have that are new?
Yeah, there is a ton of challenges, and I think, well, the main reason is that the area is much younger, right? So all the things are not yet well established as in electronics. So there is a lot of different material platforms. There is a lot of different, let's say, diversity of tools for design, for data analysis, and so on. It's still the applications, also it's an open area. Where will be the main applications for photonics, right? So how to make a choice out of it. And of course, having all this zoo of different things is maybe a little bit difficult to manage, but I think it's also very exciting because we can really innovate and we can do some things differently than how it's established in electronics. So we can try to, bring some fresh, new methodologies into this area. Of course, keeping the best practices from semiconductor electronics at the same time.
Frank, do you want to add something here?
You saw me thinking. Yeah. Well, I don't want to simplify things, but if you look at the development in the semicon, at the end of the day, we were working in silicon. We still do, still mainstream. We were making transistors. We still do. And the drive there was, let's say, to make these smaller and shrink. And I know that in the course of time, the architectures of the transistors have changed. But you could say, in that sense, it was more or less a given field than that industry optimized. And I think in the photonics area, again, I'm no expert, but there are still so many different ways of things that we could really use photonics. Of course, there's telecommunication, but there's also photonics processing, and nobody really knows how that will work, or everybody knows it should work because it'll help us. So there's still a lot of uncertainty there. So that's not, that kind of makes the comparison also complicated. I think the challenge for photonics is much larger than ASML had when they started making steppers, to be honest. I don't want to step on anybody's toes, but that's the way I see it.
I mean, in semicon is very easy. You have IMAC roadmap. IMAC took the leadership, put a lot of, they defined the roadmaps, and the whole industry is aligned around those roadmaps. So there is also a common agreement on what should be done next and where the industry should go. Very crystal clear. I think a lot of people know. And in photonics, we are still missing that. Who's the leader? Who's driving that? Who's setting the standards?
Yeah, I'm sorry, I have to respectfully disagree. It wasn't easy, and it wasn't IMAC. It was everybody, and only now does it seem very clear. I think the semiconductor world, a bit of personal history. So in 2000, I quit my job in corporate consulting, and I became a university professor again, and founded my own small consulting company. And my two first clients were ASML and what then was still Philips Semiconductors, or NXP. And the amazing thing, it wasn't easy. There were no standards. It was very unlikely that the Netherlands will be a hub for semiconductor manufacturing. Why on earth? Why not Silicon and Asia?
Yeah.
So there were no, but the main thing is there wasn't a fully integrated supply chain. Just as, for instance, several of the Japanese companies and the American companies had. So you really had to collaborate on this open innovation frame, and gradually standards emerged. And the bigger that ASML became, the bigger they could, of course. If you're in every standard setting committee, then you're going to win anyway. So I think that's really, before we suggest that now it was easy in the past and now it's difficult. No, it was difficult back then. Let's learn those lessons. And in fact, I would certainly invite all our Japanese friends here to join that open innovation ecosystem for photonics with us Dutch, because nobody now has an integrated supply chain.
That's a good remark, because that shows the maturity of the semicon, right? We 20 years ahead of further, so that seems easy, given. And now we're looking at back lessons learned, and it's about open innovation, driving it together. But still, we need somebody to take the leadership, right? I don't know. Yeah, it looks like you want to say something. Yeah.
Well, yeah, I discussed with some colleagues from Belgium, from universities. And in general, standardization is considered a very tricky process. You spend a lot of time, you spend a lot of effort, you don't really, like the effects will be seen only after a couple of years of these activities. And yeah, you also need to bring people together and kind of organize them talking. Everybody sees very early standardization as a threat to innovation, because you're basically limiting your own opportunities. But I think PITC is actually in a quite good position here, because we already work with multiple companies, with multiple institutions, and we are actively participating in various standardization activities through IEEE, for example, or through road mapping events globally. So I think yeah, that's basically we can take this role, and we are eager to do this and to move this forward.
No, very nice. If you are, that's the ambition for you. What do you expect or would like to give to Japanese audience here, and any call for action or call for collaboration? Do you want to say something? Yeah.
From me, yeah, sure. If well, companies see the need or possibilities in standardizing some things, please reach to us, talk to us, and I will be really happy to hear, you know, which existing standards can be used, or which new directions of standardization can be developed. So please, yeah. Find us, either me or any of my colleagues from PITC, and we'll be happy to discuss this.
Yeah. And I can imagine building the indium phosphide pilot line in Eindhoven will help also have access, you know, firsthand. You're going to build chips, hopefully a lot of them. So that will give you access to a lot of information that you could help also with accelerating that process, right?
Actually, that's something what we missed, is that the ownership of information is very tricky question. Yeah, the raw data contains a lot of IP, and you know, how do we share it between partners? I think it has to be taken with a lot of care. Foundries are not very eager to share the data. The companies who make the end product also, you know, it's their IP. So how do we look at both data sets at the same time without destroying IP of each of the owners of this data? That's so the data is there, but yeah, I think we are not using it in the most efficient way.
Yeah. Okay. So there's still work to be done. We are approaching the end of our panel. Any last remarks or points you want to make?
Call to action.
Yes.
So again, I've seen a couple of Japanese companies now, and I have deep respect for the engineering capacity and the smartness and the quality. But I also believe that if you really want to accelerate development, you have to, let's say, believe in the ecosystem, dare to connect, dare to be open, and to combine your efforts to accelerate the innovation. I think we have to do that.
No.
And we're there to help you.
Thanks. Henk.
Yeah, only briefly. Combine the open kimono
Yes.
approach of open innovation with drinking cups of coffee, good tradition in Brabant, informal, or as the Japanese would say, nemawashi, and join the crowd.
Yes.
That would really be my call for action. And don't be like some world leaders that only think that if I give you something, that I lose something.
Yeah.
You get something back too.
Yeah.
Usually more.
Thank you very much.